안녕하십니까? I still cannot speak Korean, so I will ask for the ones who want to follow Korean to go through the instant translation.
네, 저희가 지금 동시 통역 서비스가 제공되고 있으니까 영어로 발표하실 거니까 영어가 이제 불편하신 분들은 통역 서비스를 사용해 주시기 바랍니다.
Thanks for the opportunity to be here again. I will try to give on these 20 minutes an overview how we see the energy system nowadays globally and some examples in Korea. How Siemens is using the existing technologies to our own operations and how we are supporting customers to realize digitalization and specifically AI on their businesses, and some concrete examples also globally, some in Korea, to help showing some real examples that may be able to apply to your own businesses as well. Well, I guess that's not new for anybody. We know that the energy system has changed drastically in the last decades, where we used to have a one flow in terms of the electrical energy, very passive consumers, and few power stations. And now, we have different sources of energies. We have bilateral flow of energy, and you have a grid system much more complex. So we have more and more source of energy. Most of the investments in the last year we see going toward renewables, wind, photovoltaic. There's some studies saying that the last 10, 15 years, almost half of the investments globally will be with renewables. Those renewables they don't run 24 hours, right? So you have a change also in your capacity. Some of them, like wind farms or solar, they are massive. They need a lot of area. They are specifically in some locations only available. So you also need to bring this energy to the load centers. We see these consumers again more active, the prosumers, or in some countries even called flexumers, as flexibility is quite important on this system. So you have different business models also being implemented. And to connect these different ends, consumers, producers, it's important to have transmission lines, upgrading the existing ones, so you can bring the energy that's being generated to the central locations where the energy is expected. We see several kinds of technologies being applied today. We know for the past 15, 20 years how that changed the way we interact with others, the way we get information, the way we buy things, how we use services, specifically mobility. More recent, we can see also a lot of ICT in the healthcare environment. And nowadays we can see globally that in the industry, mainly on the manufacturing, that's also being greatly impacted. That's been done in phases on those different industries due to the complexity, to the regulations, and we see on the energy system, that's also getting there. We see some examples already, and definitely that's a way to go. When we look to the different revolutions of the industry, and maybe the last one is more an evolution than revolution. We see things being done for the last 5, 10 years, and probably will take another 10, 20 to be fully implemented. We can even say that the second one, where by the way Siemens started being alive, is the electrification. And the second one focusing automation, and then digitalization came to take more of these automated factories, operations that are pretty much electrified, but to be able to, by integration, by using data that are being generated there, to bring this to an upper level of efficiency of productivity. Siemens, just to give you an idea how much we are investing, more than 50% of our business is on electrification, power generation, transmission, distribution, another 20% plus with automation, and a lot of services, more or less 20% to supporting customers on implementing and maintaining and taking more of it. And already predicting how much IT would also help the industry and the energy environment. In the last 15 years, more or less, Siemens started investing heavily and has developed a complete suite of software, hardware, and solutions around digitalization. And using the data that's being generated to provide what we call digital services. So not to be only reactive, fixing things, trying to predict by experience, but using real-time data, comparing to the models with the digital twins to be able to anticipate or even avoid for problems. And we are doing that in our own factories. We have around 300 facilities around the globe. So we are also trying to improve our ways to do it, increasing sustainability. So here are some examples how Siemens is being recognized in doing so. Around the fifth location on the global top 10 green companies, and at the same time investing heavily to take more value for innovation with IT. And if you realize, most of the companies on the top 20 positions, they are purely IT organization, companies that are in the market for the last 5, 10, maximum 20 years. And Siemens, with 160 years in operations, is also investing a lot. At the same time, the market's getting more competitive. We need to take more for the existing assets. So being able to increase the uptime, the availability of these machines, being able to, when they are running to the full capacity, being at the same time compliant with our regulations, environmental, and so on, and providing transparency to work on this environment more and more complex. And the way to do so is definitely using digitalization. So we have built a portfolio that covers the whole value chain of a product, starting with solutions for designing and simulating any kind of product, machine, or operations. So you can do on a PC, in a virtual environment, the definition of what you want to produce in the future, how you want to change, then the steps that are needed to produce that specific product, then you can simulate in several dimensions. So when you start building something, you are able to detect a lot possible failures, make sure that you are reach your requirements in terms of your product, your availability. And later, using the data that those machines, those sensors are generating, trying to anticipate for problems, trying to find better ways to optimize your production and your energy consumption. Here, quick examples how digitalization is bringing benefits. The first one is our own factory in a city called Hamburg in South Germany. It's considered one of the most automated factories in the world, receiving several awards. This factory is keeping the same labor force for decades, around 1,000 employees, and we got a question before about it. And by automating, by bringing digitalization, this factory today produces 8 times more than it used to produce 10 years ago. At the same time, with the so-called digital twins, with the ability to simulate, with new ways to make the production lines more flexible, more than 120 products are produced in the same day, different products. And the quality, that is also a challenge to improve at the same time, has also reached levels quite impressive. But we are helping a lot of other companies to do the same. So Maserati, in one of their newest models, they are able to design totally this new model in a virtual environment, validate acoustic, ergonomics on the passengers, the layout, and they reduce in 1/3 the time to market of this new model without building a simple prototype. So when they went to the physical world, they were able to start producing much faster. By doing this in this virtual environment, by building a production line, knowing the different combinations, they offer to their customers today a huge numbers of combinations. And the line is also much more efficient. So they are producing a car much more complex that are defined by the customer when they place their order, and they still produce 3 times faster how they used to produce before. This is about energy specifically, so we monitor more than 20 buildings of this company in US by getting all the data points about the energy consumption. Not necessarily a person in one building would detect a problem because the energy consumption is within the range they are expecting, but by comparing, by doing some more complex analysis, they are able to identify insights where a specific location could improve compared to another one. And that brought around 10% of savings on their energy consumption. Here about mobility, so some railroads in Russia in very harsh conditions, by also monitoring the railroads, the trains, providing this data to expert centers, they are able today to run these trains in almost 100% of their availability. And here in Korea, we are finalizing a project now. It's a power plant in Incheon, where by using machine learning, we are optimizing the operations of a gas turbine. And currently, we are expecting benefits between 15 and 20% of NOx reduction. Other examples about how this distributed energy system is being implemented, how we are helping companies. The first one on your left is steel manufacturing in Germany. They have a battery capacity locally that helps to ramp up a gas turbine in case of a blackout on the surroundings. The other 3 are examples of microgrids that are used in remote locations, campuses, small cities, also for possible blackouts in the surroundings, but at the same time to bring more reliability into the system. And to be able to do even more, so even if you have everything electrified, if you have everything automated, we know things don't go exactly like you planned it. Quality of material, environmental conditions, integrity of machines and softwares may fail. So the idea is getting data, compare to what we have planned, and transform these massive sources of information in real value. So Siemens has built an IoT platform called MindSphere. And again, one of the questions before about competition is much more collaboration nowadays. So it's much more combining the different know-hows that companies have. And the idea of Siemens was creating an ecosystem where we provide this robust platform based on our know-how, the connectivity to different industrial assets with hardware and software, very secure, but also providing an open environment where through different interfaces, other companies can develop connectors for their proprietary protocols for their own machines. This platform is comprise a lot of analytical tools, and on top of that, specific applications developed by Siemens in the areas that we know, but most of them developed by partners that, based on their know-how, they are bringing also specific solutions. So that helps the small companies, huge corporations, to use an environment where all the IT, the security, the different locations are covered, and they can focus on the development on their applications based on their own know-how. Then when you talk about artificial intelligence, yeah, we see these different steps, but it's important to start from the beginning. So you should have a strategy, should have a vision, but also, as mentioned before, you may not know exactly if all the ideas you bring the results you want. So you should prioritize the ones that you believe, you bring the best ones. Then you start getting information, the insights that automatically you get may help you to review that prioritization, and then you move towards a more intelligent, complex environment. It's worth to mention that most of the prerequisites for artificial intelligence are available, right? So machine learning algorithms, they are in place for decades. Computer power, it's available. Databases to store this data and through the data clouds, and open platforms to process this information, yeah, in terms of applications. And one use case for AI is also helping troubleshooting. Again, some problems may still happen due to external conditions, and machine learning can also help to identify quickly the root cause of those problems and automatically or manually providing the right direction to the operator, yeah, the problem can be fixed quickly. Here's more details about the architecture of the solution that we implemented in this power plant in Incheon. So the idea was going out of the local control loop by processing a huge amount of information, the key variables on that process, and running different simulation scenarios. Siemens also developed a specific simulation environment for neural network. We feedback the control system that will have the most optimized set point, balancing output and the emission. And as I mentioned, yeah, the potential benefit is around 15%. And also in power grids, so to help find disturbance, failure locations, for example, in wind power, that's quite difficult for an operator or a local controller. Detect all the external perturbances on the system. A machine learning is much more effective. So that's real examples where we are applying to find the disturbance and the failures and suggest the countermeasures to avoid those. And just a summary, yeah, about the energy system, more and more renewables, the sector coupling, so energy to gas, battery, and so on. Digitalization is an enabler, is the accelerator for these challenges. Business models, again, about the prosumers and private and public together. And definitely, cognitive computing will be massive. So we see already some concrete examples and more that will help the industry as well. With that, I would like to thank you and hopefully provide some answers later. 감사합니다.